దీని మీద వస్తున్న విజయ్ ఇక్కడ
யுவனேஷ் சார் வாய்ஸ் கேக்குதுங்களா? என்னோட வாய்ஸ்
வீடியோ முடிஞ்சதுக்கு அப்புறமா இது போயிட்டு இருக்குன்னா உடனே நீங்க என்ன பண்ணுங்க, நீங்க ஸ்டார்ட் பண்ணுங்க.
Parvati ma'am.
Yes. Success is not the key to happiness. Happiness is the key to success. If you love what you are doing, you will be successful. Good afternoon and a warm welcome to everyone to gathered here. On behalf of Anne Violet Arts and Science College, I welcome you for the 2 days virtual international conference on Computing Technology and Mathematical Science 2020. A warm welcome to all the eminent speakers and guests from all over the country from different walks of life who have joined us today to share their knowledge and vast experience with the student community. Anne Violet Arts and Science College by Chevalier N.R. Dhanapalan sir in the year 1997 is imparting the value-based and comprehensive education to both men and women, thereby making each student self-reliant and self-confident to face the challenges of the millennium with the motto of seek, strive, succeed. Working hard to deliver holistic quality education, our college provides various platforms, organizer programs, certificate course, sports, cultural, etc. to make students versatile. Being an NAC aggregated and ISO certified institution with a short span of existence, or college has developed into a pioneer institution in providing quality education. In the contemporary scenario where the technological innovations is under huge transition with the fast-paced growth of digitalization, it is essential to update ourselves with the recent technology and infusion of mathematics and science. And as our department, BCA, BSc Computer Science and Mathematics, along with the IQAC of the college, has rightly arranged international webinar on Computer Technology and Mathematical Science 2020, which is need of the hour. This webinar focuses on introducing emerging technology and opportunities in field of computer technology. This webinar will provide ample of ideas and knowledge for students and scholars who wish to pursue their PhD in computer technology and mathematical sciences. Without further ado, let's begin this session. Now I invite Mrs. Mognavalli ma'am, Head of Department of Mathematics, to welcome to gathering and also to introduce the department.
Good afternoon to one and all present here. This is Mohanavalli, Head Department of Mathematics, Anne Violet Arts and Science College, joining you all for the international virtual conference on the topic Computing Technologies and Mathematical Sciences, organized by Department of Mathematics along with IQAC team of our institution. Brent Terry's quote goes like this: welcome the challenges, look for opportunities in every situation to learn and grow in wisdom. Quoting Brent, I take this opportunity to welcome everyone who has gathered here to learn and grow in wisdom. First of all, I would like to welcome our chairman, Chevalier Dr. N.R. Dhanapalan sir, our secretary, Mr. N.R.D. Prem Kumar sir, joint secretary, Dr. P.R. Premchand sir, principal, Dr. Kamala Balakrishnan, and vice principal and IQAC coordinator, Mrs. Zafia Solomon, for this 2-day international conference. I extend a warm welcome to our resource person, Dr. C.R.K. Reddy, Professor, Department of Computer Science and Engineering, Mahatma Gandhi Institute of Technology, Gandhipet, Hyderabad. Welcome, sir. I also extend a warm welcome to the heads of various departments, faculty, students, and participants from other college, researchers, delegates, scholars, and our technical team for this conference. Before we begin the session, I would like to brief about our department. The Department of Mathematics was established in the year 2007 to provide basic knowledge of maths every year. The department conducts bridge course for non-maths first-year students, effective teaching techniques like chalk and talk, assignment, assessment, seminar, quiz, student-teacher interaction, group discussion, paper presentation, and PowerPoint presentation are followed to make students understand the complex concepts in maths easily. Our department students in the past 3 years had secured more than 8 university ranks under the guidance of energetic and passionate faculty. 8 of our department students had secured centum score in the university, and few has also received best going student award. Our department alumni students have reached higher heights in pursuing PG and research in various colleges, and also are recruited in various public and private sectors. The department molds students with a strong mathematical foundation, analytical and computational skills, and abstract understanding to aid graduates, apart from syllabus, to make them expertise in the field of mathematics. And to facilitate industrial knowledge, our department club Multiply frequently organizes enrichment programs with external experts. To mention a few among them, in 2021, Dr. S. Lavanya, Assistant Professor in Mathematics, Bharat Women's College, Chennai, was the chief guest of the Power of Mathematics webinar in June 2020. Mr. N. Manigandan, trainer in Unikids Academy, Chennai, was the chief guest of Applications of Vedic Mathematics webinar in July 2020. In 1920, Mrs. R. Krishnaveni, Assistant Professor in Mathematics, Mahalakshmi Arts and Science College for Women, Chennai, was the chief guest of Basic Concepts of Real Analysis guest lecture in Feb 2020. Dr. S. Sheikh Alam from Sri Vidya Professional Academy Director, Chennai, was the chief guest of How to Prepare for Competitive Exams training program in September 2019. In 1819, Dr. S. Lavanya, Assistant Professor in Mathematics, Bharat Women's Chennai, was the chief guest of Operation Seminar in Jan 2019. Pachapas College, Chennai, was the chief guest of Statistical Methods Seminar in August 2018. In 1718, Dr. M. Ramesh Kumar, Assistant Professor in Mathematics, Sasta Engineering College, Chennai, was the chief guest of Basic Analysis Seminar in Feb 2018. Dr. K. Thirusangu, Associate Professor in Mathematics, SIVT College, Chennai, was the chief guest of Applications of Graph Theory Seminar in September 2017. In 1617, Mr. Jesdas Arogyam, Assistant Professor, Ellen Government College, Poneri, was the chief guest of How to Face Competitive Exam training program in Feb 2017. Dr. Jaishankar, Assistant Professor in Mathematics, RMK Vivekananda College, Chennai, was the chief guest of Statistical Methods Seminar in July 2016. In 1516, Dr. S. Karthikeyan, Assistant Professor in Mathematics, Dr. Ambedkar Arts and Science College, Chennai, was the chief guest of Statistics and Operations Research Seminar in September 2015. In 1415, Dr. V. Madhu, Assistant Professor in Mathematical School of Advanced Science, VIT Vellore, was the chief guest of Complex Analysis Seminar in August 2014. The department striving had to enable students to shine in their career by providing workplace skills and mathematical knowledge, will continue to provide quality and need-based education to students. Once again, I welcome you all for today's conference.
Shall I start, ma'am?
Just a minute, sir. Just 1 minute, sir.
Okay, fine.
Thank you, ma'am. Now I welcome Mrs. Usha, ma'am, Assistant Professor, Department of Mathematics, to introduce our chief guest speaker of the day, Dr. C.R.K. Reddy.
Good afternoon to one and all present here. On this occasion, I would like to introduce the chief guest of our session, Dr. C. Ramesh Kumar Reddy, Professor, Department of Computer Science and Engineering, Mahatma Gandhi Institute of Technology, Gandhipet, Hyderabad. Sir has completed his Bachelor of Engineering in CSE and Master of Engineering in CS. He is a recipient of doctoral degree from Central University of Hyderabad on the topic Analyzing Programming Dynamics through Stochastic L Systems. He is a proud and successful teacher with a teaching experience of 23 years. Under this guidance, 5 scholars have completed their PhD and 4 scholars are pursuing their PhD. His area of experience are problem solving using C, data structures, algorithm analysis and design, automata language, theory of computations, computer organization, data communication, artificial intelligence, etc. As a eminent personality in the field of education since 1995, he has participated and presented 80 research papers on diverse topics in both national and international seminars and conferences across the country. Words and time are insufficient to mention all academic accomplishments like participation in national and international conferences and presentation of papers. To mention in numbers, he has published 27 papers in international journals, 10 papers in international conferences, and 18 papers in national conferences. Apart from paper publication, he has attended and organized various FDPC courses, workshops, and conferences. As an eminent personality, he has served as a co-chair for ICITE 2018 held at Osmania University, Hyderabad, and has also delivered an expert lecture on dimensionality reduction multivariate analysis FDP conducted by Department of IT CBIT. He has successfully completed the sponsored project from ISO MDB, integration of texture segmentation and optical character recognition for multimedia databases at AICTE in 2000 for 8 lakhs. He is the member of professional body CSI and is also holding significant positions in the university. Currently, he is the head of the Department of Mahatma Gandhi Institute of Technology, Gandhipet, Hyderabad. So, with this brief introduction, once again, I welcome Dr. C. Ramesh Kumar Reddy for this session, sir. Thank you, sir. Now the session is yours. Thank you.
Thank you, ma'am. Thank you for your kind words.
Thank you, sir.
Good afternoon, everybody. And first of all, I would like to congratulate the management of Annai Violet Arts and Science College on conducting a national or international level workshop or conference on computing technologies and mathematical sciences 2020. And my sincere thanks to Chief Patron Chevalier Dr. N.R. Dhanpalanji, patrons Prem Kumarji, Prem Chandji, Balakrishnan, Dr. Kamala Balakrishnan, ma'am, and Mrs. Jafia Solomon, Vice Principal, and convener for the program, Dr. Sudha ma'am, and co-conveners, Mogan Valli ma'am, and Vinod ma'am, and my dear participants. Thank you. Thanks for inviting me for this particular conference. So let me share my screen, and before that, yep. So I have as in fact it's an honor, I can say, to be a speaker in a any national or international conferences, and that too I am more happy to converse with the UG and PG students. I came to know that our Annai Violet is offering UG and PG courses, and some of the PhD scholars are also going to join, followed by some of my colleagues and co-colleagues. So, is the screen visible, Mogan Valli ma'am? If screen is visible and I am visible and audible, I can
Yes, sir.
start off.
It's clear. You can start, sir.
Fine, I think. Right. So, before going for analyzing program dynamics through stochastic L systems, that is the topic. Before that, the main aim of computer science itself is to develop a robot which can behave like us. Can anybody guess why it is so? If you see in nowadays technology, like yeah, I can say my mom, and if I go back to our earlier days of farming, where everything used to be man-made. Nowadays it is not so. If I take the agricultural sector, nowadays mechanization has come into picture. Similarly, in the case of this particular teaching learning methodology also, if I go back to my school days, where teacher used to be there, and he used to write something on the board, and we have to sit in front of him, and we used to listen, and we have to recite. That's what is known as rote learning. That's how we have learned, and some of my colleagues here. But coming to nowadays generation, thanks to COVID, I will say, thanks to COVID, actually, this particular online teaching platform has gained. It has picked up. So thanks to technology once again. So the main aim of computer science is to develop. Basically, we are lazy. Human being is a lazy person. Like given a choice, my students would like to have 100% of attendance without coming to the classes, without writing, or by writing a bare minimum, they would like to expect 100% of the marks there in the examinations. And of course, given a choice, I think majority of us don't want to go to offices if monthly salary is coming into our salaried account. I mean, might be bearing a few. So that's the main reason. Since we are lazy persons, we wanted to develop a machine which can do the donkey job or hard work for us people. That is the main concern for our automatic pilot vehicles and automatic pilot of aircrafts and all these things. Wherever you look into, it will be any car manufacturing company and all that. Automation has or mechanization has come into picture there. So nothing wrong there. Now comes the question: once you want to develop a particular machine or a program for a given a task, we have to define that particular task precisely. Which particular problem for all my fellow colleagues and students, whenever you are going to soon you are going to get into good jobs, let it be hardware jobs or software jobs or whatever it may be, problem definition is going to play a vital role in our lives. First of all, you want to define the problem precisely. For which particular problem I would like to give it a try. As I was mentioning, it can be automatic pilot vehicles, or in our case, one of the engineering student, by sitting at home. In AP, power cut is more like only our farmers are going to get a power cut. Power only for a few hours. That too, that changes from week to week. Sometimes it is at midnight, 12 to 6 o'clock in the morning. So, which is a tedious task for the farmer to go there and on and off and switch on the water pump and all that. So, what he has done, one rural boy, I will tell you, one rural engineering student, not even Hyderabad, in fact, Mahbub, one of the rural student has picked up this particular project. Nowadays, cell phone is most widely used by each and everybody. Technology we might not be knowing whether it is a FM transmission or AM transmission or whatever, but we are using that particular cell phones right from our milk vendor to farmers and and everybody. So using that particular switch phone right from home, he used to switch it on by using IoT devices. He used to switch on and off the pump, and not only that, now automated water filling of our tanks. Like the moment water level goes below particular level, automatically pump will be switch on and water will be filled. Once it is reaches particular level, automatically that is going to be cut off. Similarly, automatic opening of the doors that you have seen in the airports and some of the malls in Madras or Hyderabad or whichever. So this particular automation. So first point, you have to define the problem precisely. After defining the problem, to solve that particular problem, the machine can understand only zeros and ones. This is a dumb machine, let me tell. So it's a machine language is only zeros and ones, only binary language, which we are going to call it. Whereas our language is powerful. Even though you might be hating Hindi, but I have to accept that particular fact that that's better than English. Why means in English you are having only 26 alphabets there, whereas in English it is only 26 alphabets. I'm damn sure in Tamil. Can somebody tell me how many alphabets are there? Vali ma'am, how many alphabets in Tamil?
247.
247.
Yeah.
No, ma'am, it's too high. In Telugu, it is 56. Actually, that's what we are going to call it as Achulu and Hallulu. I mean, that Kavatu and Dirghalu, Kaka, Kiki, Kuku type, that Kadirgam, Gudi, and that's a different issue altogether. But basic symbols, alphabet, like A, B, C, D, E, that is 26 alphabets. In Telugu, I, U, U, which we are going to call it as Achulu and Hallulu, that is 56 symbols, followed by this Gunintalu, Dirghalu, or whatever. Point is, with only two symbols, zeros and ones, this particular ATG is mapped into ASCII code. Similar, and that power of the language which we are going to call it as. In English, you are going to write RAMA. That RAMA, I can take it as Rama or Rama. In Telugu, we can clearly write Rama is different, Rama is different. That's where this particular Dirgham is going to come into picture. So, to solve any particular problem, in the machine, what we have to do is define the problem precisely, then go for algorithmic development. That's where mathematics is going to come into picture. Once you, what is an algorithm? Algorithm is step-by-step way of solving a particular problem. Once you do that, then we can do the coding business in the machine. For to do the coding business, since I cannot code it in zeros and ones, earlier let us recall in the 40s and when the machines has come into picture during World War 1945. We have started with coding with machine language only, zeros and ones. Then came the punch cards. Then the 1970s, Bell Labs has developed the, of course, followed by assembly language code. Then followed by Bell Labs in 1970s developed the C language. That's all third generation languages, C, Pascal, Basic, and all that. Then came the invention of object-oriented languages after C++ and whatnot and all that. Once object-oriented languages come into picture, that's then followed by Visual Basics, Visual Pascal, then followed by HTML and markup languages and whatnot and all that. Of late it is Python language. So now each language is again we need mathematics. Just I want to correlate in this session the mathematics and its correlation to, in fact, mathematics is the thing. From mathematics only computer science has come into picture. Okay, so that's how define the problem precisely. To solve that, develop an algorithm. To after developing an algorithm to code it in the machine, you have to take up the help of a language of our choice. It can be machine language or C, the assembly language, or third generation or fourth generation or fifth generation languages, or interpretation languages, whatever. So take the help of these languages, do the coding there, and run it or execute it. Once the program, what is program? Set by set instructions or line by line instructions, which has to be run on this particular machine, which is based on Van Neumann architecture. Line by line execution of a program is nothing but Van Neumann architecture. Fine. Once it is going to run it, then program is going to, once it is running, then I am going to call it as dynamics. Given a particular input, how it is going to run under different conditions is program dynamics. For example, if you want to sort a particular numbers, like in my class, suppose 200 students are there. I would like to find out, I want to first list out them alphabetically. That means sorting A, B, C, and whatnot. Anna Violet, like engineering colleges or degree colleges, I want to sort it out. Anna Violet is there. And Dindi College is there, Madras University there, or Chennai University is there. So ABC, whatever institutes that are available, I want to sort it out. Then that's going to be a sorting problem there. Then how to sort this particular problem? So what you are going to do, you are going to compare institute 1 name with institute 2, and you check it up whether it is A or B or C to start with. And once it is Anne, so A is there, so you are going to put Anne College at the top. Next followed by Anne B set or whatever. So like this, colleges by colleges, you are going to sort it out. For that, again, comparison is needed. So that's what you are going to call it as logic or algorithm. Now, after developing the program, just comparison is not sufficient. I can run it on a fast machine, supercomputer machine, and I can claim that my program is working perfectly and it is much better than the other person the program developed by the other person. But that's not the case. That is a priori analysis. After running into the machine, analyzing the program's performance is secondary issue. Before running it into the machine, I want to analyze that particular program, which is nothing but priori. Before running it into the machine, priori analysis is needed there. So that priori analysis is going to be carried out. Whereas in our particular topic of today, we are going to do the, once program is running, how to visualize that, which particular block program is running is of importance. And again, time and space is going to be important. That's what we're going to call it as average case, best case, and worst case. That we will see. Okay, so to do that, actually Lindenmayer is the one that L system stands for Lindenmayer systems. So in the Lindenmayer systems, what we're going to do is, given a particular program, specifically block structured program, whatever languages, these third generation languages and fourth generation languages, all of them are based on a particular grammar known as context free grammar, CFG. So if your people are aware of the earlier machine Wittenberg, so that is based on this Van architecture, and the grammar is nothing but context-free grammar, which we are going to define as VTPS, that are set of variables, terminals, productions, and a starting symbol is going to be available. So that VTPS grammar is available. Based on that particular rules only, all the computer languages are developed. In fact, if you remember, again, Chomsky hierarchy is going to come into picture. All the grammars, I can classify them into type 0, type 1, type 2, and type 3. Type 0 is the superset for which Turing machine was developed. And type 3 is the starting machines, which we are going to call it as regular grammars there. Recognizer for that is finite automation. Best example for finite automate I can say is our fan switching off on and off. Like if I switch on the button, then fan will be on. That is, if I switch off, then fan will be off. So that simulation of that particular on and off, I can do it with the help of a logic gate, AND gate and OR gate, followed by NOT gate, which we are going to call it as together. NAND gate and NOR gate are known as universal gates through which whatever program we're doing that will be implemented in the hardware level. Fine. So coming to the current topic, our main aim is to map a given program into Lindenmayer systems. So let us quickly go through that. So Lindenmayer systems is going to be defined as a triplet here. Set of variables will be there. That P stands for the program, and W is nothing but the initiator. Can you people guess here what is happening? If you see here, D0L systems, deterministic 0 Lindenmayer systems, B is deriving you A is deriving you AB. Again, if you see here, A is deriving me AB, B is deriving you A. So there are two productions I can say. So what are those two productions? B is deriving me A is one production. So that's where this P is going to come into picture. A is giving me AB. So that is again another production. So there are two productions. With the help of these two productions at various levels, these strings are going to be generated. So set of variables. What are the variables here? The one which is going to vary. What is varying? B is varying and A is varying. What is the initiator here? What is the starting point? B is the starting point. What are the productions? Two productions. B derives A and A derives AB. So together, this is what we are going to. This is an example of a just Lindenmayer system, deterministic Lindenmayer systems. Now let us. Okay, I think is coming into picture. Fine. Now let us talk about stochasticity. What is stochasticity? Stochasticity is nothing but probability. If you, yeah. So here that earlier Lindenmayer system we have defined it as set of variables, productions, and initiator. Here this particular pi, the probability with which these rules are going to be applied is going to be defined. That's why stochasticity has come into picture. Why stochasticity? If you observe the nature or let it be our human body itself, if I do the human anatomy, my right hemisphere and left hemisphere, or if I, for example, if I chop off a particular individual, or if I compare my right leg with the left leg, or right hand with the left leg, and right eye with the left eye, it is not symmetric. There will be some minute differences are going to be there. That randomness will be there. To bring the, and that's true with the nature also. Any tree, if you see also, it's not symmetric. Of course, you might be trimming it. That's different issue. To bring the symmetricity, you are going to trim it. That is different. By nature, it is not symmetric. It is random. So to bring that particular randomness, probabilities are going to come into picture. So once the previous three rules like F derives F plus F, F minus F, and F, we will interpret that. We will be interpreting it soon using turtle graphics. Once you apply these three rules, the trees are going to be generated like this. These are the trees that we have obtained. So for that, how we have obtained that? For that, you need the turtle graphic there. That F or D, I can take it as draw forward, and plus means take right turn and draw it. Minus means take left turn and draw it. And this particular left parenthesis and right parenthesis in this particular productions is nothing but wherever the cursor is there at that particular point, push that contents into the stack. The moment right parenthesis is going to come, go back and retrieve that particular cursor back. So that's where stack is of important. I hope in data structures you might have heard about stack, which is going to use the principle of last in and first out. Fine. So now let us see the program dynamics through stochastic L systems, which is involving three stages actually. So in the first stage, given a program, we will model it into L systems. In the second system, the probabilities are going to come into picture. In the third stage, we are going to visualize the tree. And all of us have written programs in C. In the C language, our main, I can take it as the initiator, that is the starting point. And from main, the different branches are going to take place. If I want to compare three numbers and I want to print the biggest of three numbers, so what will be the program there? If x is greater than y and y is greater than z, assuming x, y, z are the three numbers, x is greater than y and y is greater than z, then print of x is big. Else, x is greater than y is greater than x or y is greater than z. I will compare whichever. If so, then y is big. Else, z is biggest number. Now, this is going to take, as we were mentioning, the program will take different branches there. As and when it is taking different blocks, can I do this particular tree-like structure representation was the main idea. And let us see whether we have succeeded there or not. For example, let me take the quicksort program there. And as we were mentioning, I want to sort the students list or colleges list. So for that, we have an algorithm. This is nothing but an algorithm which has coded into C language there. So mainly consisting of three blocks there. Like if you remember, the numbers are going to store it in an array. The first element is the pivot element or key element. The next element, I'm going to place a pointer I, and the another pointer J, I'm going to take it and I will place it after the upper bound. I will compare the second element with the key element. If it is less than the key element, then I will keep on incrementing my ith pointer. Similarly, jth pointer, I will come. I will compare the last element, upper bound, whichever is there, with the pivot element, first element, and if it is greater, then I will keep on. If it is less, sorry, if it is less, if lower bound is less, then I will keep on decrementing the jth pointer. So at some point, I and j are going to be swapped. That is the basic idea. Once it is swapped, that means the key element has reached its jth position. At that position, I will swap it, the kth element with the jth element, and I will divide the array into lower half and upper half and apply the quicksort procedure once again. So first point, given a program, identify the blocks. After identifying the blocks, this is how we have identified the blocks there. So we can say incrementation of ith pointer and a decrementation of jth pointer and swapping of I and j. So these are the main blocks. And for that, the rules defined, if you see on the right hand side corner here. So it is plus db minus dc. So plus d is take right turn and draw. Minus means minus dc is take left side and draw. dd is nothing but draw straight. So this is how the given elements, we have taken 5 elements or 6 elements, 0 to 5 index. So 6 elements are taken there. 32 is the first element or key element or pivot element. So I pointer is pointing to 12th initially. So jth pointer is placed to upper bound. So compare and do the swapping businesses here. Once we have done this, and we using those turtle graphics there, plus db and minus db and dd, we have drawn it. And if you see, for the given input 32, 12, minus 9, 5, 18, and 13, so this is the tree which has been obtained here. Okay, and for another input, you can see some right branches and left branches are available there. For another data distribution, for another input, these are the another tree which we have obtained there. If you observe here, completely right branches are missing, only left branches are there. Can anybody guess why this is going to happen and when this is going to happen? Where right branches and left branches are going to miss? Any guess? Anybody? Once the data is already sorted, let it be ascending or descending case. Let it be ascending or descending, we can see. So that is the worst case scenario for a quicksort program. So that's where we have observed that in the case of ascending, you can see number of swaps are 0 there. Similarly, in the case of descending, number of swaps are 0. Incrementation of ith pointer is 0 in case of ascending. It was a 60 in case of descending case. Decrement of jth pointer is happened 1250 times, and the descending case, it is roughly 1200 times it has happened there. So for Poisson distribution, for uniform distribution, whatever data distribution is going to happen, let me tell you friends, mathematics is directly involved there. Each one is having a unique formula. Poisson distribution, all of us know that all of you are mathematicians. So Poisson distribution formula is available, uniform distribution formula is available. So using those particular formulae, given a data, we have to generate the different data sets depending upon this uniform distribution or Poisson distribution. Anyway, so our concern is mainly identify the basic blocks. After identifying the basic blocks, identify the map them into, like as I said, plus D, minus DB, and DD and whatnot and all that. Map them into this particular program rules there, then map it into the tree-like structures. That's what is visualization. Once visualization is done, then even a layman can see that this particular side branches as taking place in case of data is descending. So to check that, this is going to be of much help. Fine. So that has been mapped here into a graph there. So you can see here in the case of data is data set descending order, like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, whatever. So descending case sort of thing. You can see here the number of I module and H and J, that is incrementation of number of swaps, incrementation of pointer I, decrementation of pointer J has happened respectively 0 times, 800 times, and 1200 times. So this is how the mapping has taken place in the form of a graph there. So that's what will be helpful in case of a quicksort visualization of program dynamics there. And can you people tell me what is the worst case time complexity of a quicksort? Any volunteers or participants? Okay, fine. I think it's not a. I think students were given a separate link, ma'am. I think they are not in the group.
Yes, sir. Yes, sir. They are in YouTube, sir. They contact through
YouTube.
YouTube.
Okay, so they cannot participate with the conversation. Okay, fine, brother. Yeah, let me thank you. Okay, let me continue. So in the case of quicksort, like to analyze, as I was mentioning, any program analysis is important. What type of analysis? What is the time it is going to take, and what is the space it is going to take? Time versus space will be a key measuring parameter as far as the program is concerned. And nowadays, space we are not worried. Why means space is very much abundantly available, but time complexity is going to play a vital role there. And the worst case time complexity is of order n square in case of quicksort, and the average case time complexity is n log n times. So again, to compute this, again mathematics is going to play a key role. So to summarize this, so let me summarize whatever we have covered till now. So what we did, we want to analyze the program dynamics using stochastic L systems. So first we have seen what do you mean by Lindenmayer systems, consisting of 3 tuplets, set of variables, initiator and productions, and that is mapped to a blocks. A program has taken quicksort, we have taken it, and this particular quicksort program has been mapped into various blocks there, and these particular blocks are mapped into turtle graphics, like plus right side branching, minus right side branching in case of increment and decrement, and draw straight lines in case of a swapping of a given program. Once mapping is been done, we have visualized the program behavior. Once program visualization has been done, even anybody, not even it cannot be a computer expert. You might be seeing the data points of in Hindu paper. If you see, I love sports actually. So if you see there, every time data points is going to come into picture. Or in case of COVID situation also, state by state they will compare, and they will say this many cases are reported, and this state is at this point 5 days back, and this state is at this particular position, increase or decrease of COVID cases or whatnot. It can be, so that's a beautiful mapping analysis is going to take place. Visualization will is going to help there, and there again, visualizing program behavior, mathematics is going to play a vital role there. So to sum it up, a wide tree is going to imply frequent branching there. So a narrow tree branching implies that only a certain portion of the program is executed. So whatever programs are not executed, blocks of the programs are not executed, we have to devise special test cases for those. Okay, friends. So that's the end of the first part. And when, as and when the, in fact, I was asked to give, I was given time up to 3 only, I think 2:45. So now I will open my session to any doubts, clarification for another 5 minutes. Now it's 2:45 or 2:46. So another 5 to 10 minutes I can open for discussions.
Thank you for the valuable insights and for introducing the emerging trends in mathematics and computing, sir. The session was really enlightening, and just like the quote by American author Earl Nightingale, which states, creativity is a natural extension of our enthusiasm, and the creative topics you explained as like mapping of sample C program to L system and L systems based parameters for program testing is truly enthusiastic. Now it's time for question and answer session. Participants, you can post your questions and doubts in the chat box. Now I invite by Mrs. Bhavani, Assistant Professor, Department of Mathematics, to take over the question and answer session.
Yeah, please. Can I see any questions in the chat box, please? They can, audience can post. Yeah, I'm seeing the chat box, but no questions there. Any discussions? Like I'm not telling. I believe in knowledge sharing, and I gain from discussions only. And
Thank
we
you,
will
sir.
continue. Thank you, ma'am. Thank you. If there are.
It was a really good and inspiration speech, sir.
Thank you, ma'am. In fact, there is a continuity of the stochastic L systems is available, ma'am, which is known as the reverse Lindenmayer systems. So, as and when the time permits in future, I would like to interact with our students, and I would like to share my experience or of any other topics. To sum it up, once again, let me stress: mathematics is the basis for computer science, and without mathematics, in fact, a mathematician can do computer science, but not the computer person cannot learn mathematics. So my sincere advice to all my friends and colleagues and students is to have a grip over mathematics, more so in nowadays technology. Let it be blockchain technology, let it be artificial intelligence, where a lot of hardware is also going to be involved. If I want to develop a robot, again I need mechanical engineering is involved, electrical engineering is involved, then signal processing is going to be involved, internet of things is involved there again. So it is a combination of hardware, software, electrical and electronics. For all that, again, mother is maths only. To tell you the truth, I after intermediate, I mean during 10th class, I completed my 10th in 81. So during 10th, I told my dad that, Dad, I would like to. I'm fond of BPC. I mean, biology. I'm getting more marks in biology. I would like to go for biology there. Then he has given a motikai in Telugu. Tappa. And no, how to join in MPC only. He is a civil engineer. So, chalo, theek hai, no choice. So I have joined into intermediate mathematics and of course engineering. No regrets. To tell you the truth, even now, any doubt, again I have to go back and I have to refer to books and I refer to my colleagues and my gurus, and all of them and my colleagues follow colleague mathematicians, and most of them, a lot of them, through discussions I'm going to gain much. So that's what I suggest you people also to go through. Thank you very much, ma'am. If there are no more questions, then can I sign off, please?
Sir, shall I ask one question, sir?
Please, ma'am. Please.
What are the typical jobs related to AI, sir, artificial intelligence? And how will artificial intelligence change the future, sir?
Okay. In fact, AI is not new. Computer science, as I was mentioning, has started with the goal of developing a machine that can behave like us. If I want to develop a machine that can behave like us, like suppose now actually I'm traveling, and we have stopped at a particular place, and now I am delivering. Uh, or I want computer to go to my office and do its job, but the salary I want it to be deposited to my account. I don't want it to eat for me. I would like to have my own food, and I would like to have my own sleep, but I want my donkey job to be done by the machine there. The thing, like with that particular aim to let it be bomb disposal squad or whatever. So I don't want my manpower or my soldiers to be distracted or get hunt in the front line. I want robots to do that particular job, especially during this particular COVID situation. All that, if I can develop a machine which can act like a doctor, but with that aim only, computer science has started actually. Then, if I want to simulate the behavior of a human being, it's very difficult. Forget about simulating total human being behavior. It is very difficult to behave to simulate the hand movements. We know with how much care we can lift a baby, with how much care I can hold a glass of milk, or if it is a steel glass, how much care I needed, and if it's if it is a glass, then how much care, or with what is the firmness which we have to hold it. So many muscles and technologies are involved there. So then we went for expert systems. Then again, human being is good at what? Expert systems are gaming, interested in gaming. Which particular gaming? Again, brain game is again chess. So in 94, actually, IBM has developed a Deep Blue program consisting of arrays of computers. Man versus machine. If anybody can type in the net, they can check it up. Man versus machine program was developed, and there was a context between the then champion Anatoly Kasparov with IBM Deep Blue chess program, and ultimately the machine has won. The machine has won. That's where the learning has come into picture. Again, different types of learning, supervised learning and unsupervised learning and whatnot. Again, they wanted to simulate the neural network behavior. Then came the neural network of computer science into picture. So that's how the technology has come. Now, of late, what is happening? Deep learning has come into picture, where thousands and thousands of neurons are going to come into picture. That's what we are going to call it. We are calling it as machine learning. We want this particular machine to learn the way which we are learning. So that's where the technology is there. We are far, far away from developing a robot which can behave like us. To test that again, there is a Turing test is there. Like for example, now I am speaking with Bhavani ma'am. Is it?
Yes,
No,
sir.
no. Yeah. So I'm speaking with Bhavani ma'am. So I don't know whether Bhavani ma'am is real or she's a robot. To do that, Turing has developed a test. Yeah, last 1 minute I will cut it off. I will check it out. So I am the interrogator, and assume you are the robot, and real Bhavani ma'am is at home, for example. Then that means three different persons are at three different places, and to find out whether Bhavani ma'am is real or not, the interrogator is going to ask some questions like might be your date of birth, or your spouse and husband's name, or children's name, whatever. And if the machine can fool me that to believe that yes, you are the human being, then the developer, the person who has developed the robot, has succeeded in developing a machine that can behave like human being. That is known as Turing test. We are far, far away from that. So that's how the technology is developing. And in future, definitely, of course, that's a boon, and that's the main reason why of late there are various computer science branches, like machine learning has come into picture, business analytics has come into picture, and AI is again another emerging technology which has come into picture. And jobs are there in this particular sector. So if you people are, and if you see, IIT Madras recently has come up with an online program, IISc, I think. IISc and IIT Madras has come up with an online program, like a 3 years online degree course in data sciences. So that is the thing. Jobs are there in these particular fields, and I want you people to pursue those lines and pick it up.
So
Thank
based
you,
on
ma'am.
this, what is the importance of self-driving cars in the future, sir? Self-driving cars.
On the lighter vein, I will say it's very difficult on Indian roads, especially in Hyderabad. I can imagine the haywire where nobody is going to follow the rules there. And if we can follow, if we can, of course, in states, the population is very less there, and more or less the people will follow the rules, barring the presidents. Like even after the election results, one president doesn't want to leave. So human being like unless otherwise, whereas machine is not like that. Given a particular program, it expects like in the road, if it is a double line or yellow line and green line and one yeah, pakka white line and dotted white line, it expects that dotted white line means yes, now I can overtake, and overtaking I can take only from the right side or left side. Bhavani ma'am, overtaking is allowed
Yes,
only on right side or left side?
right side, sir.
Right side. That's what
If the road is broad.
that's what the machine is going to expect. But how we human beings are crossing our vehicles, everybody knows that. So in this scenario, in our traffic scenario, it is better not to go for automated vehicles. But automated vehicles are very much available there, and fine. To some extent, they are being used in states. Thank you, ma'am. Thanks for the lively discussion.
Yes.
So looking forward, and we'll meet at some other point in future.
Yes.
Can I sign off, please?
Yes, sir. Thank you,
Yes,
sir.
thank you, sir.
Once again,
Thank
let me
you.
thank and all of you, and it's a pleasure meeting with you people and interacting with you. Thank you, ma'am. Thank you, and see
Thank you so much.
you, ma'am.
Thank you, sir, and thank you, ma'am. Now our college students to post their e-post presentation.
அம்மா சத்தம் போடாங்க மெதுவா குறைட்டு விடுறேன்
you, student, for your wonderful e-poster presentation. Now I request the participants to kindly fill the feedback forms posted in the chat box to receive your certificate and to subscribe to our institute YouTube channel for more updates on upcoming events and webinars. Learning never exhausts the mind. It kindles interest to dig in further more. I hope that today webinars on computing technology and mathematical science 2020 will kindly the researchers and scholars to research more on this topic. We have come to the end of today's session. Tomorrow session on the topic machine learning and virtual reality will be led by Mr. B. Krishna Kumar and Mr. Rohit Prasad. I thank everyone who joined us for today's session and special thanks to our eminent speakers, delegates and guests. Thank you.